In this video, we will be going over a Mechanics 1 question for the sub-learning outcome, calculating net force on a 2D rigid body using free body diagram and equilibrium equations. Let's take a look at the figure provided. So notice that there's a beam AC that has a pin joint at C. Forces W1 and W2 are given, and we have the cable that stretches from point B on the beam to the pulley at D. Let's assume up, right, and counterclockwise is positive for the x-axis, y-axis, and moment force, respectively, and down, left, and clockwise is negative. We are told to neglect the size of the pulley at D, which means the pulley is not a factor, and to find the tension of the cable length BD, or alternatively just force FB. First, we are going to draw the free body diagram, which is going to be the beam AC with the pin joint at C. Then draw the forces we know, FB, W1, and W2. Remember to draw the reaction force RCY and RCX to represent the force that the pin joint at C is exerting. There is no moment force because C is a pin joint. Before we solve for the tension of cable BD, which we know as force FB, we want to break it into its x and y components, FBX and FBY. Applying the equations of equilibrium, we solve for the moment about C, which we know is 0. W1 and W2 are denoted as positive because they produce a counterclockwise moment about C, while FBY is denoted negative because we assume that it will produce a clockwise or negative moment. FBX, RCX, and RCY do not produce any moment about C and are therefore excluded. Rearranging and solving for FBY gives us FBY equals 100 kilonewtons. This is positive, which means that our assumption about FBY was correct. So now that we know the y component, FBY, we can use it to calculate the value of FB. Use tangent theta equals opposite over adjacent to solve for theta. We are given opposite and adjacent, so rearrange to get theta equals 48.01 degrees. Then use sine theta equals opposite over hypotenuse. We know the value of theta equals 48 degrees, and the opposite is FBY. So sub them in and rearrange to solve. FB equals 134.54 kilonewtons. And so the tension of cable length BD is 134.54 kilonewtons. For the second part of this question, we once again neglect the pulley at D, and this time are tasked with finding the reactions at C. Let's bring back the free body diagram from before, and let's start by making an equilibrium equation for the y-axis. The sum of all forces acting in the y-axis is 0, and any force downwards is negative, and any force upwards is positive. We assume that the reaction force RCY is positive. We solve for RCY and it's negative 15 kilonewtons. Therefore, our assumption was incorrect, and RCY was actually a negative force. Now solving for RCX, we create an equation of equilibrium for the x direction. This time, any force to the left is negative and right is positive. We assume RCX is positive. Solving for RCX, we get RCX equals negative FBX. To find FBX, we bring back force FB and its component forces. Remember, tangent theta equals opposite over adjacent. Sub in the values that we know and solve to get FBX equals 90.04 kilonewtons. Going back to the equilibrium equation, RCX equals negative FBX equals negative 90 kilonewtons. We have a negative value for RCX, so we know that our assumption was incorrect. Therefore, RCX acts in a negative direction. The reactions at C are therefore RCY equals negative 15 kilonewtons and RCX equals negative 90 kilonewtons.